If I said ratio, what do you think of?
5 to
Okay.
1. Something, a number to another.
Okay, one number to another. Summer said what I was actually thinking, but what you guys said was completely correct. Okay, so it's, ratio is basically a fraction or a comparison. Okay, Cookie, what numbers did you say? You said what? Something 5 to 1. Okay, that'd be a ratio. It's a comparison of okay. It's a comparison of one number to another. So you could write it as a fraction. So ratio basically is a fraction, or 3 to 4. Or, like Destiny said, you could write it like this with a colon. Right? Two dots on top of each other, 3 to 4. So the top one would be the first number, the bottom number would be the second one. Okay, so you could write it like that. It's just comparing one number to another. All right, so for instance, if I said, let's say, just making these numbers up, let's say I had 15 girls in a class and we had 10 boys in a class. Okay, and I wanted to find the ratio. So I asked you, what is the ratio of, let's say, boys to girls? All right, boys to girls. All right, so it's a comparison of one number to another number. So what are we comparing? We're comparing the boys to the girls. So the boys, if we're going to write this as a fraction, where would the boys go? On top, okay, and then the girls go on the bottom, okay? So if I'm comparing boys to girls, what if I asked to compare girls to boys? Then this would be girls on top and boys on the bottom, okay? Everybody understand that? Or you could write as a colon, but most of the time, we're going to be writing it, most of the time, not all the time. A few times we'll throw the colon in here, all right? But most of the time, we'll write it as a fraction, all right? So you just see how many boys you have. How many boys in our class? 10. And how many girls in our class? 15. Now, you don't keep it like this. What do we always do with fractions? Always reduce your fractions, okay? So let's reduce the fractions. So what goes into both of these? 5 goes into this twice, and 5 goes into this 3 times. So what's my ratio? 2 to 3. So if I asked you the question, what is the ratio of the boys to girls in this class? I just picked numbers that would reduce real nice and easy, okay? So that's why I didn't count how many are in here. But is that what it is? Yeah. So I figured, yeah, I figured it wouldn't, it would work too well. But this number works exactly what I wanted to do. So if I wanted to say what is the ratio of boys to girls in here, you would say 2 to 3. Does that mean that there's only 2 boys in this room and 3 girls in that class? No, it doesn't mean. It means for what? For every, right? For every what? 2 boys, there would be 3 girls. Does that make sense? All right, so I mean, you could have a whole bunch of people in here, and still the ratio could be 2 to 3. You follow me on that? Yeah. So when I say the ratio is 2 to 3, it doesn't mean that there's only 2 boys and 3 girls. It means for every 2 boys, there's going to be 3 girls. Make sense? Yeah, you've seen this stuff before, haven't you? It's not brand new. All right. What's another thing that we use ratios a lot? Example they give in the book is a TV screen. All right. And here's TV screen, widescreen TV, and they say that that would be 32 inches and this would be 18 inches. All right. So nowadays, almost who's got a widescreen TV in their house? Widescreen, yeah, a lot of people do, and it's getting a lot more popular nowadays than it used to be, because that's about all they sell. You can barely go to a place. If you're going to get a brand new TV, you can barely go to a store and get a TV that's not a widescreen TV. Now, what do we say? What do we mean by widescreen? Well, the dimensions are a little different. The ratio is different on a widescreen TV as it was with a normal standard TV. Do you know what the ratio was for a standard TV? Standard definition TV? Like that TV up there, okay? What's the ratio of the width to the height? Anybody know that number? It's actually 4 to 3. It's not an exact, it's a little bit of a rectangle, okay? But it's really close to a square. What if it was a square? What would the ratio be if it was a square? 4 to 4, but that 4 to 4 would reduce to what? 1 to 1, right, 1 to 1. But TVs are not perfect squares. They're a little bit rectangular, right? Like that TV hanging right there. Okay, it's 4 to 3. But now we have these widescreen TVs. All right, and what is the ratio? Now, if I measured this, that'd be 32 inches. This would be 18 inches. By the way, this is just an aside, but when you go to buy a TV and they say, well, I want to go get a 50-inch TV or something like that, what is the 50 inches? Is it the width of it? Is it the height of it? It's the diagonal. Very good. It's the diagonal. It's from one corner to the other. So if you're going to go out and buy a 50-inch TV, that's what you're buying. You're buying it's the diagonal. Okay, that's the length that you're finding. Did you guys know that? A lot of people thought it was just like how wide it was, right? But it's not. It's the diagonal. And we could figure out the diagonal to this if we wanted to, couldn't we? We'll do that in a second just for fun. But right now, what are we trying to do? We're trying to find the ratio of these sides. So what would you do? Let's go, we'll call this the width, and we'll call this the height. Let's find the ratio of the width to the height. That's how they normally do it on a TV. So the width to the height. How would I do that? What's the width? 32. What's the height? It's 18. Now we don't say, is it 2 to 1?
I mean, just kidding.
So what number divides evenly into both of these? Let's simplify it. 2 goes into 32. How about 16 times? And 2 goes into 18. What? 9 times. Does anything go into 9 and 16? No. So what is the ratio? It's 16, 9. 16 to 9, right? And when you see that word, remember how we put that little colon right there? We use the word 2, T-O. All right, so 4 to 3. Or this would be what? 16 to what? To 9, all right? Nobody's seen that before? If you go to a store, electronics store or something, and you look at it, you'll see this 16 by 9. I do video a lot, and nowadays, almost not everybody, but a lot of people are now switching over to high definition. Okay, and high definition format is 16 by 9. So I'm a little geeky when it comes to the photography. Well, when it comes to everything, but especially when it comes to the photography and the video and all that kind of thing. And they talk about this all the time. I mean, they'll talk about 4 to 3 formats and 16 to 9 formats and different things like that. My camera, I just got a new camera. It looks like a regular still camera, but it does high definition video on it, and it's got different settings on it. It's got standard definition. It's got some high definition settings like 30 frames per second and 60 frames per second and 24 frames per second. But the high definition settings are all 16 by 9. The standard definition is 4 by 3 or 4 to 3. All right, so these are really, really popular numbers when it comes to, televisions or high definition video and things like that. That's 16 by 9. I can almost guarantee that somewhere on the box, if you buy a widescreen TV, you'll see 16 by 9 or 16 to 9 on there somewhere, and that's what they're telling you. Okay, that means for every 16 you go this way, you go 9 this way. Does that make sense? Okay, and that's kind of like a format that people are kind of used to today, is the 16 to 9. All right, just thought I'd throw that out there. Okay, what's another place we use ratios all the time? Well, what about like a batting average? For baseball and softball fans, batting average is a very important number, isn't it? So how do you figure out somebody's batting average? Lonnie, you're a big baseball player. So how do you figure out the batting average? What's that? You have no idea? Oh, you got to know. If you're going to be a baseball player, you got to know. So look, you're going to learn something new today, so this will be good. So watch. How do you find your batting average? Because like if somebody's hitting like 350, if somebody's hitting 350, it's actually, they always put a dot in front of it. Okay, it's the number of hits that you get. Right, from a lacrosse player, he knows how to find the batting average, okay? So the number of hits, what's that? Well, good. Over the number of what? At-bats. Okay. Now remember, when you're playing baseball or softball, if you get a walk, that's not considered an at-bat. Okay, so if you get on, let's say you get on once, but you get 3 walks in a game, and you get 1 hit, you're only up 1 time. Technically, okay, as far as batting average is concerned. So a walk doesn't help. Now there is a number, Daniel. What number does consider on base percentage does consider walks and things like that. Okay, I don't know about errors though. Do you have any idea? I don't think it counts as on base percentage though. Even on base percentage, because you get on base. I wonder if that counts. It probably does, because on base percentage is always way higher than what your batting average is. So like if you get a walk, if you walk 4 times in a game, your on base percentage is really, really high because you're 4 for 4, right? You batted 1,000 basically on base percentage. But if you had 4 walks in a game, you were up 4 times and you got 4 walks. Technically, in your batting average, doesn't count at all. All right, it's like you never went to bat at all. Okay. So anyway, how do we do this? We'll come back to this 350 right here. So let's say you're up 100 times. We'll make this really easy for us. Okay, so you're up 100 times, and you got let's say 27 hits. All right, you got 27 hits, and you're up 100 times. All right, so it's 27 over 100. But in batting average, we don't leave it a fraction. Okay, if you watch TV, you'll put it into a calculator. Now you can do this very easily since I put 100 on here. Yeah, just here's your decimal and just go 2 places. So it's what? It's 0.27, isn't it? But they don't say, and that's 27%, right? So they don't say, okay, well, this guy's hitting 27%. They don't say that. They actually use 3 numbers. They put a 0 right here, and so they say, oh, they're batting 270. All right, so when you hear somebody's batting average, if you're watching a game on TV or something like that, or today, go to the baseball game today. They're having a dedication for Joe Feely Field, right? And they're asking a bunch of people to come. So if you can hang out after school, even if you play a sport, ask your coach if you can go down there. That'd be good. Yeah, it's supposed to be a real nice big deal. Okay, so that's why I'm wearing red, because they told us to wear red to show school spirit and stuff. So yeah, so there you go, worked out. All right, so yeah, it's right after school. Head down there. I'll be taking pictures, and it should be a good time. All right, and first day of baseball season is always a special time, and softball season too. Sorry, I'd probably go to more softball games than I go to baseball games. So anyway, here we go. So hitting 270. 270 is not bad. All right. I mean, you could make a team. You could be a starter on a team and be hitting 270. What if you're hitting 350? You're a monster, okay? You're in the Hall of Fame. If you can average hitting 350, and what does that mean? That means for every 100 at-bats, how many hits do you get? You get 35 hits. So you actually fail how many times? 65. You actually fail 65% of the time, and you make the Hall of Fame. That's a pretty good deal, isn't it? All right? To fail 65% of the time, and you make the Hall of Fame, and you're one of the best batters ever. I mean, technically, if you hit 350, because it's very difficult to hit a baseball, especially in the pros. Okay, it's very difficult. It's one of the hardest things you can do is to hit a baseball, especially with all the curveballs and the crazy pitches they have. Even in softball, you got crazy pitches. I mean, you got risers, you got sinkers, you got balls that go in and out. You got all kinds of crazy things, and they're only what, like 50 feet in front of you. Okay, so. But it's a little bigger, though. All right, and it is closer where the angle that the ball can actually travel is decreased. So in baseball, you're further back. You're 60 feet, 6 inches away compared to 50. I think is it 50 feet for softball? 43. Wow. And I play old man softball. I play slow pitch softball, and we're 50. Yeah, I'm a pitcher, and I pitch. It's 6 to 10 feet. It has to be above 6 feet and below 10 feet to be able to pitch the slow pitch softball. But anyway, we're hitting rabbit trails. And that's not the easiest thing. You'd think it would be really, really easy. But when the ball's coming in at a crazy angle like this, it's not. I mean, it's easy to hit the ball, but to actually get a hit sometimes is not as easy as you would think. But in softball, your batting averages are way, way higher than 350. I mean, if you're hitting under 500 in slow pitch, I'm talking old man slow pitch softball, if you're hitting under 500, you're not really hitting that great. I mean, you want to hit at least 1 out of every 2 times in slow pitch softball. But still, that's only 50%. So I mean, real good batters can hit a lot higher than that. But in baseball, in Major League Baseball, if you're hitting 350, you're really, really good. Okay. Yeah, and like high school baseball, my guess would be your averages are probably this or higher than 350 because, high school, they're not pitching quite as fast and they don't have quite as much movement on the high school pitches and stuff as they do in the pros, even though I wouldn't want to stand there and I wouldn't want Lonnie throwing at me. I've seen Lonnie throw. He throws hard, and I wouldn't want to and I wouldn't want to be hitting off of him. I'd probably be bailing out especially if you threw a curveball at me, I'd probably be on the ground. So anyway, all right, that's enough of that. Let's do some more. How does this have to do with anything geometry? Well, I'm glad you asked that question because we've got an answer for you. So watch what we're going to do. We're going to draw a triangle.
Oh, great.
Oh, great. All right, and watch what they do here. They call this angle 3x. So it's not 3 degrees. It's 3 times a certain number, isn't it? All right, and this is 5 times that number, and this is 4 times that number. Okay, and what they're going to ask you to do is they're going to say, they're just going to say solve for x. Now, they could ask you for the angles as well, okay? But right now, we're just going to solve for x. So if I call this A, B, and C, they very well could say find angle A, find angle B, and find angle C. In fact, we'll solve for x first, and then we'll find A, and then we'll find B, and then we'll find C. Is that all right? Okay, so what in the world are we going to do with this, and how does this have anything to do with ratios? I don't see any fractions, I don't see any ratios or anything like this. But this doesn't mean it's 3 degrees, is it? It's 3 times a certain number, 5 times that same number, 4 times that same number. So the 3x represents how many degrees that angle actually is. So what do we know about the 3 angles of a triangle? What do? They add up to 180. So what do you think we're going to do here? Yeah, we're going to add them up and then set them equal to 180. Okay, we're going to add them up. So 3x plus 5x plus 4x equals what? 180, right? Because this 3x represents how many degrees this angle is. Does that make sense? All right, it's not 3 degrees because look, 3 plus 5 plus 4 doesn't add up to 180, does it? But 3 times a certain number plus 5 times a certain number plus 4 times a certain number, we don't know what that certain number is, but we do know that they add up to 180. All right, does that make sense? So let's add them up. 3 and 5 is 8 plus 4 is 12x equals 180. And then what do we do here? Divide by 12, and I think that's 15, isn't it? Yep, it is. X is 15. Does that mean this is 15 degrees? No, it means that's what x is, and we were asked at the beginning to find x. But now, what if we, so x is 15. What if we want to find angle A? What do we do to find angle A? 3 times 15, right. And 3 times 15 is 45. And then angle, I'll tell you what, let's do angle C next. That's easier math. 4 times 15 is what? 60. Now, if you wanted to, you could just go 45 and 60 is 105. Take that away from 180, right? And what is 180 minus 105? 75. Or you could just go what? 5 times 15, and that's also 75. It works both ways. And so look at that. They didn't tell you any of the angles, did they? But they told you the ratios. They told you the comparisons. It's 3 times a certain angle plus 5 times a certain angle and 4 times a certain angle. All right? So that's how you can find that stuff. That's not so bad, is it? Pretty easy, right? So remember, just this, this, and this. They don't set them equal to each other because they're not necessarily equal to each other, are they? All right? They add up. The sum of those angles add up to be 180 degrees. Why 180? Because a triangle, right? All the angles add up to 180 degrees in a triangle. Good. All right. Enough of that. Let's move on to something else. We'll see how this works. I don't think they do too much of this with like real geometry stuff. They're just kind of leading you up because we will do this a lot later. Almost the rest of the chapter. We're going to be doing the stuff that we're going to do right here in a second. We're going to be doing this stuff with some geometry figures, with triangles and quadrilaterals and things like that. Okay, but right now we're just showing you how to do this. This is called, you probably remember this, cross multiplication. Do you remember that? Now a lot of people, multiplication. Can't talk and spell big words at the same time. So I got to sound it out. All right, so cross multiplication is 2 words actually, a little more space in there. When do we use cross multiplication? A lot of people do this. Now, don't write this down, all right? Of course, hardly anybody's taking notes anyway, so I guess I don't have to tell too many people. But watch, if I had this, if I had 2/3 times, I don't know, just make this crazy, 5/7. If I asked you to multiply these two together, a lot of people incorrectly think this is cross multiplication. It's not. You don't multiply diagonally when you have a multiplication problem. What do we do if it's just a straight up multiplication problem? Just multiply what? Straight across, right? Straight across. So this would be what? 2 times 5 is 10. And 3 times 7 is 21. That's just regular old multiplication. This is not cross multiplication. All right, I almost hate to even put that up there. I'll erase it because I don't want you to think that that's cross multiplication. Where does cross multiplication come in? Well, let's do this. What if I said 4 over, I don't know, 12. Let's go 4 over 12. What does 4 over 12 equal? If I was to reduce this, we've reduced a couple things already today. What would this be if I reduced it? 1 over 3, right. Now, it would be 2 over 6, but if you take that even further, it would be 1 over 3. Now, watch. Here's where cross multiplication kind of comes into play. Let's do some different color. If I wanted to check to see if this was right, you could always do this to check to see if this fraction actually does equal. Do you see the difference between this and what we did just earlier and I erased it? Before, there was a multiplication sign in between, right? What's in between here?
Equal.
Equal sign. So the only time you use cross multiplication is when you have a fraction set equal to another fraction. When this is an equal sign, then you can use cross multiplication. So let's do this. When we say cross, we're going diagonally, okay? We multiply diagonally across like this. So if I multiply that together, what's 4 times 3? It's 12. And then I multiply diagonally this way. What's 12 times 1? It's 12. Do they equal each other? Of course they do. So is this fraction equal to this fraction? Absolutely. Okay, that's a nice way to check to see what it's equal to. What if I had something like this? We'll use the same numbers just to make it easy. What if I said 4 over x equals 1 over 3. Now you may be able to just look at this and do this in your head, and that's okay, but they're not always going to be this easy. I just picked one that was super easy. In fact, we know it, we see it right there, we know exactly what this answer should be, don't we? But let's do cross multiplication and we'll figure out what this answer is, okay, by cross multiplication. Again, they're going to be more difficult than this, but I'm trying to start off with something easy. So watch. If I have a fraction set equal to another fraction, by the way, we call this whole thing right here, when you have a fraction equal to another fraction, we call this a proportion. That's the first time you've heard it in this chapter anyway. It's not the last time because we're going to talk about proportions a lot. I mean, we're going to say this over and over and over again in this chapter talking about proportions. What is a proportion? It's when you have a fraction set equal to another fraction or two equal ratios. You follow me? That's a ratio, isn't it? And that's a ratio. If they're equal to each other, that's a proportion. Everybody got that? It's an important word. We're going to use it over and over again. So make sure you understand that. Now, if we wanted to solve this proportion, what would I do? What do you think? I would cross what? Multiply. That's right. I'd cross multiply. So we're going to multiply like this. Do you see why I put those lines in there? I'm just showing you which numbers I'm multiplying. So what's x times 1? It's x. What's 4 times 3? It's 12. There's your answer right there. So x should be 12. So is 4 over 12 the same as 1 over 3? Absolutely. Okay? Again, that was about as easy as you could possibly get right there. They're going to get a little more difficult, but the process is really the same. Let's do another one. I'm picking an example from the book. Here's a real ugly one. I don't think there's any way that you could probably do this in your head. I don't think I could. 31.5. This looks really close to this problem right here, right? You've got your x on the bottom, left, and everything. Everybody see that? So let's put the little marks in here. We cross multiply. So we multiply diagonally. Multiply those together. We multiply these together. And then we put an equal sign in between. All right, everybody see that? Excuse me. So I always like to do the one with the x first. It doesn't really matter which one you do, but I think having the x on the left-hand side is the best way to do it. So if we multiply across like this, what do we get? It's 21x. Then we put an equal sign, and then we multiply this way right here. 6 times what? 31.5. Okay? And then, what do we do to get x by itself? Yeah, get rid of the 21, divide this by 21. Okay? 21. That cancels out. X equals, what would you do here? Oops. I would use a calculator, wouldn't you? Where'd my calculator go? Did I erase it? Oops. What's going on? Cancel that. Cancel that. Yeah, let's cancel it. Sorry. Hold on. Let me get that calculator up and running. I don't remember deleting it. So I got to do this, and I do this, and then I do this. There it is. All right, now let's go back to our picture here. And so what do we got? 6 times 31.5. So 31.5 times 6, right? And that equals 189. Divide that by 21, and that equals 9. Comes out perfect. It's not always going to come out nice and pretty like that. Okay, sometimes it will be a decimal. That's fine. In this case, it came out real nice, and the x is equal to 9. So x over 9 is the same thing as 21 over 31.5. Pretty simple, isn't it? Yep, just cross multiplication. Let me see what else. I think we're pretty good. Let me find another one. Yeah, let's do this one. It's the same thing, but I'll let you. We got a few minutes here, okay? We've been going pretty good. Write this down, and I want you to solve for it. And it's 9 over x plus 4. I want everybody trying this. Go ahead. Everybody working on this. You should be taking notes already, so just put it right in your notes. If you're not, get a scrap piece of paper out. If you're doing Bible homework, which I see a couple of people doing, okay, put that away and get your notes out and do this. I want you to solve for x. Go. Alright, you should have had enough time to do this, so let's do this. Let's cross multiply. And it doesn't matter which one you start with, okay? It could be the bottom left to the top right, or it could be the top left to the bottom right. It doesn't matter which one you do. Let's just start. Let's do it this way, like this. So if I multiply them together, it's going to be 9 times x minus 1. Now, some of you might have just been able to distribute that in your head, and that's fine, but I'm going to write all my steps out. Then you put an equal sign in between. Don't put a times. I've seen people do that. Put an equal sign in between and multiply these two together. So it's going to be 7 times x plus 4. Now what do we have to do with that 9? Distribute, right. So that's 9x minus 9, and this is what? 7x plus 28. Get the x's on the same side, so what are you going to move over? The 7x, yeah. So I'm going to subtract the 7x from both sides. Now in the same step, I got rid of the x. Let's get rid of what now? I got the x on the left-hand side. So yeah, let's take this minus 9 and put it on the other side. So how do we get rid of this minus 9? I add a 9. I've seen people put minus 9 here. Is that going to get rid of it? No, negative 9 minus 9 does not cancel out. But negative 9 plus 9 cancels out. So I add a 9 to both sides. So that cancels out, that cancels out. 9x minus 7x is 2x, and 28 and 9 is 37. And we divide by 2, And really, does 2 go into 37? No, I would just keep it just like that. I wouldn't even put it into a calculator and get a decimal. I would just leave it just like that. Okay, now can you put it into a calculator and get a decimal? Sure, was that 18.5, I think, right? If you wanted to, you could write 18.5, or you could write 18.5, but I wouldn't even bother. Look, you already got your answer right here. Why even bother trying to write it like this, you know? When this is good for me, I'm perfectly fine with that. Good with that? All right. So I'm going to give you a worksheet. You're going to have several things on the worksheet. You'll have several problems like we just finished doing. You'll have some stuff like this. Now, you will have a problem on here. I don't want you to get too confused. But what if I told you the perimeter? What if I said that this side was 3x and this side was, I don't know, 7x and this was 2x? Nope, that wouldn't work. What if I said that this was, let's say, what if I said that this was 6x? That'll work, okay? What if I had said this is 6x and 2x and 7x, and I said the perimeter of this triangle was, I don't know, 58 inches, okay? What would you do to find what x was and to find the lengths of all three of these sides? Now remember, on the one we did earlier, you knew all the angles added up to 180, right? Well, what do you know about all the sides? They add up to 58. So it's the same basic problem, isn't it? Except they tell you what they add up to be. So what would you do with this 6x, 2x, and 7x? add them up. So 6x plus 2x, I don't know if this comes out nice and even. It probably doesn't. I just made these numbers up. And that's 58. And then what do? Add them up, solve for x, and we go from there. Okay, so you will have some problems that we'll talk about the perimeter. So, but they'll tell you the perimeter, okay? So they'll tell you what they add up to be. So you add them up, set them equal to what they add up to be, and then you can do your math and solve for x. So I just wanted to throw that out there because I figured some of you are going to look at that and say, we didn't do that in class. You'll do some stuff like this. It may not be batting average, but it might be something else. And they'll give you the number of whatever to whatever, and you have to figure it out. Okay, so they'll give you some word problems, like the boys and girls thing, right? They'll say, okay, they might give you something like this. Watch. The number of boys to girls was 2 to 3. And they tell you how many boys you had in the class. All right, let's say they said that there was 7 boys in the class. All right, and they ask you to find the number of girls. That's what you would do. That's how you would set it up. So if they said the ratio of boys to girls was 2 to 3, that's what I would write. I'd put B over G equals 2 to 3. Then they're going to tell you one or the other. They're going to tell you either how many boys there are, or they're going to tell you how many girls there are. And you just replace that boys with the 7, and now you can cross multiply, can't you? Wait with me on that? Now that's a kind of a weird number because 2G equals 21, so there'd be 21 over 2, or what? 10 and a half girls. But, you know, if I gave you 8, watch, if I gave you 8, then it would be a little bit better, all right? All right, you with me on that? Yeah. Okay, so that's the kind of stuff you're going to see on the worksheet. So it shouldn't be too hard for you. I'm only giving you one side this time. Isn't that nice? But there's quite a few problems on it, so that's why I only gave you one side instead of 2. All right, have that done for tomorrow. Get your test signed. Remember, how many points am I giving you? This is one and only shot. Okay, 5 points this time instead of 2. All right, so take advantage of it. No matter what you got on it, 5 points is going to help everybody. All right, so it'll make a difference.